Hello, Professor. Today I'm going to talk about input space partitioning testing for our Chapter 6 software testing. Um, so for input domains is basically input domain is a type of functional testing where it is tested by the application and given inputs and evaluating appropriate outputs. In order to test, we also need to see these parameters that defines the scope of the domains. So for example, um, we also have to see the parameters that are listed as like the data which is read from a file, if there are any global variables, also user input levels, also the domains, the input parameters are also partitioned into regions. Also, we also have to look at least one of the values is chosen from each region. So, what are the benefits of the partition testing? So, which is basically it is really equally to apply in several levels of testing, um, in the input integration and system. Also, like relatively, it's also easy to implement without the use of automation, which is amazing because I know that it's for some developers who are testing, automation could be really lengthy process, and also like it could be really time consuming, and they really need to have the expertise to also implement the automation and testing. And it's also very easy to adjust to provide like more task and less testing, and we don't even need to do that much like background implementation on the space partitioning testing. So which means like, we don't have to be an expert in the background of, doing this automation testing, and which will help them to basically move forward with their task. And also like input space is also required when we're doing all these testings. So moving forward, partitioning domains. So partition domains, the input domains D and the partition scheme of D are also under a software test into a different blocks. So it points with these blocks basically points within each other, where they're basically treated the same, but the system under each task. When we look at all these classes, we're also allowed to look at the implementation of the software and see the specifications of each block. The partition must satisfy these both properties in order to do the domains, which is block must be pairwise disjoints, which means there should not be overlapping between these blocks, and also together blocks also cover the domain of the D. Under the partitions assumption, we also choose values from each block, and also each value is assumed to be equal useful for testing. Application for testing would be like looking into the characteristics in the input functions, parameters, and schematic descriptions. We need to basically partition each characteristics. Then we can choose the testing by combining these values from each characteristics. And there are a bunch of examples that the partitions are being used in, like in input devices, especially just like CD, DVD, VCR, or any like computers. Choosing the partitioning basically, we have to is pretty easy, and it's really, but it's also very easy to get it wrong if when we're trying to do the testing implementation. And if we take a, like, let's say an order file F, each characteristic from the file should be tested and should be addressed properly in order to make sure that it's sorting in ascending and descending order. We have to make sure that these files are partitioning into the correct order in order to go from the next blocks. And the length of the file would be 1, and in these 3 blocks, the disjoints will not satisfy. So properties of partitions, if the partitions are not complete or disjoints, it must that the partitions not have been considered carefully. So if they are not complete or the disjoints are there, so we have to make sure they are considered enough carefully enough, and in order to make sure the partitions are complete. They should be carefully reviewed with any designs, and we can also model these inputs domains into 5 steps. And these steps are listed as like, step one is basically move us. Step one and two are move us from the implementation in the abstract level, um, and the designing abstraction level from chapter 2. Step 3 and 4 are basically entirely at the design abstract level, which brings us back bound to the abstraction level. So as you can see, modeling of the input domain are like listed in these 5 steps, which we need to identify the teasable functions, what they are, what they do. We also have to find all the parameters of these functions. Step 3 would be modeling these input domains, and step 4 would be applying these test creation and choose these appropriate the combination of values. And then step 5, we redefine these blocks into test inputs. So these five steps are really crucial in modeling the input domain. So when we create the 2 approaches of the input domain modeling, we're taking the 2 test cases, which are interface-based approach, which is also used for developing the characteristics directly from individual parameters. So we do this individually in the interface-based approach, and the application is simple, and also the particularly automated. It's basically partially automated in some situations. Functionally based approach would be like the develops the characteristics from behavioral view of the program under the test. It's also hard to develop these, and it's required to have more design diagrams, which is also really time consuming, and it also can result into like better testing, and but it will be fewer tests, which is really less effective. It'll be better testing, but it'll be less effective. Step 1 and step 2 of identifying functions and parameters and characteristics would be a creative engineering step. Make sure that there are more characteristics are being addressed, means there are more testings are being made. Candidates for characteristics would be like any preconditions and postconditions, relationships among these variables, also relationship of variables, which are really crucial. And also they have to have better characteristics few blocks, which means there are going to be less mistakes, and also we also have to implement less tests in order to see the functionalities of these testings. Step 3 of modeling the input would be we need to partitioning the characteristics into blocks and values. It's very creative, in a very creative engineering step. And more, that means more blocks means more testing. So if there are more blocks that the testers have to do, that means they're going to be have to do more time consuming and that to evaluate from these testings. And the strategies for identifying these values would be including valid and invalid and special values. We also use sub-partitioning from blocks. I also explore the boundaries of domains and also try to balance the numbers of blocks in each characteristics. And finally, we also check the completeness of and the disjoints of each testing in the blocks. Using more than one IDM, so many of the programs that we may seem to have dozens of hundreds of parameters. So that means, the parameters means they're gonna take more than one levels of testing. So in which way IDMs we can create into small, where it will divide and conquer for each blocks. And it's okay to see if the IDMs are overlapping. So that means the variables is more than, that means there are more than one variable in the IDM. So step 4 of the choosing the combination of values would be once the characteristics and partitions are defined, the next phase is to basically choose the test values. We have this given criteria we can choose from, and also the effective subsets. So the most obvious creation is basically to choose all the combinations that varies in these blocks. And the all combinations of the blocks from uh, must be tested. All the characteristics from these combinations should be thoroughly tested, should be reviewed carefully before we implement the next step. So this is basically the all combinations given from the slides uh, from the book, which is, these are considered as the second characteristic of Tang is given. So we can see as that the characteristics are split into B1, B2, B3, and B4, and also their requirements are Q1, Q2, and Q3, which means, like we mentioned before, they have to be greater than 1, or in each scenario they're basically greater than 1, equal to 1, equal to 0, and less than 0. So make sure we also have to relabel the blocks also from characteristics of A, B, and C. Moving on, I'd say the ISP criteria from each choice. So each choice coverage is one of the values each block for each character must be used, and also one test case should be also be implemented. As you can see, for here that the picture has shown is A1, B1, C1, and the substituting values are also given with their blocks. So ISP criteria pairwise, each block yields few tests, and it's cheaper and but it's ineffective. It's cheap but it's ineffective when we use the ISP criteria for pairwise. Another approach combines was like values with other values. Also, pairwise coverage is also a value from each block from each characteristics must be combined with a value from every other block from other characteristics, which makes it cheap, but it's also really ineffective. Uh, ISP criteria for T-wise would be the natural expression of that defines a T-wise, and it's required of the combination of T values instead of two. T-wise coverage is TWC, which is value from each blocks for each group of T characteristics must be combined, and the number of tests is at least the whole product of T and the largest characteristics. Another moving on ISP criteria base choice would be, testers sometimes can recognize that certain values are important in this choice, and it's also the domain knowledge of the program. And the best choice is basically, criteria is block will be chosen from each characteristics, and base test is formed by using the base choices from each characteristics. Subsequent tests are chosen by holding all but one choice constant and is used for non-base choice in each characteristics. So the base choice would be basically, the base choice must be feasible, all of them must be compatible. Each base choice can also be from end use from point of view also, so which is, also we can summarize as simplest, smallest, and first in some ordering, and testers should be document why the choices were made. So testers should also document why why the certain choices were made, and they should also implement all of the compatible and the feasible points that when they order all these blocks. So moving on to ISP criteria, multiple base choice. Multiple base choice ISP criteria is basically at least one and one possibility more base can are chosen from each characteristics, and base tests are formed by using each base choices from each characteristics at least once. And also subsequent testers are also chosen by holding all of the base choices constant for each base testing and using each non base choices in other characteristics. So as you can see, like in the picture here from the slides, as an example where the base M test MI is implemented in the characteristics of the formula, whereas the summation of the Q where I equals 1, where all these bases are implemented from using this formula. As we can summarize the ISP coverage, we can see that all the combinations of the coverages, how they're implemented from, we start from all combination coverage, moving on to T-wise coverage, multiple choice coverage, and then we go to pairwise coverage. From there, we go to each choice coverage in the end. So we can implement it's basically implement for two ways if it's T-wise coverage or multiple base coverage, and basically moving on, it will go to pairwise or either base choice, and finally it would we can implement each choice coverage, which would be the combination for all of these coverages. Input space partitioning is basically, we can summarize that it's fairly easy to apply with no automation. So basically, no automation is required when we're using ISP. It's convenient ways to add more and less testing. So basically, there's less testing being done and more tests are being added, more tests are being implemented. Application of all levels of testing, which could be unit, class, integration, or system, and also based on the input space of the program, also just not the implementation. So hopefully, this summarizes the whole input space partitioning in chapter 6, and hopefully, moving on, there are more implementations we learn about, but uh, I would say summarizing this would be it was really fascinating to learn about this chapter, and also it was really innovative. So I learned a lot, and also making the slides also helped me, integrate how these testers are being created and what each functionality of these coverages were. So,